Very good evening. Today we are going to start leveling. So before going to start, we will discuss what is our problem and how to solve it. So suppose it is a surface of Earth where we have marked some point on the surface. We are namely saying it is these are A B C D E F. So we have to find out the elevation of this point. So for calculating the RL or elevation, first of all, we will set our instrument either side of this point. We will prefer from where all these points are visible. So we can set it anywhere. So one side we will set our instrument. Okay. And other points which we are saying ABCD are our stations at where we have to calculate the RL. So for calculating RL, first of all we will set our instrument and we will look towards our survey line. Okay, so it is our level line or axis of our telescope. So this is our axis of our telescope. This is our axis of telescope. It is horizontal line and other points are our stations. So we will one by one put our staff on these stations and we will take the readings. Okay, so you can see this line will strike our on our staff and we will read the readings. Okay, in in this sequence of reading you can see among these all station D is at lowest elevation in terms of elevation and F is at highest elevation. But if you will see here, the highest staff reading will be at D. Okay, and lowest staff reading will be at F. It is F is at highest elevation, so staff reading will be lowest, and at lowest elevation, staff reading will be more. So it will be the sequence. Okay, if you are at lowest elevation, that time your staff reading will be maximum, and at highest elevation, your staff reading will be minimum for a single setup. So among these all stations, there will be one point whose elevation is known. Suppose we know the elevation of A. That time we will say it is a benchmark. Benchmark is point of known elevation. Suppose elevation of A is known. Okay, known means suppose I am saying it is 200. That time we know the elevation of A. That time it will be our benchmark. And what is the benchmark? Benchmark is a point of known elevation. Reading taken at benchmark. Okay, reading taken at benchmark is known as backside reading. So backside reading is reading taken at benchmark. So it will be your backside reading. And what is benchmark? Benchmark is point of known elevation. And for among these all readings, the last reading which we will take, that one is known as foreside reading. So one will be your means reading taken at benchmark will be your backside reading, and last reading will be your foresight reading, and all other readings it will be your intermediate side reading. It is the fundamental for this surveying means terminal basic terminology. Now we have to find out the elevation of all other points. So for calculating the RLs, there are two methods. One is height of instrument method and second is rise and fall method. Height of instrument and rise and fall method. We will see both the method one by one. Okay, so we are going to solve one problem which is given in our worksheet. So you can see there is one problem. We are going to read this problem. The following consecutive readings were taken with the help of dumpy level and 4-meter leveling staff at 30-meter intervals, and instrument was shifted after 4th and 11th reading. So readings are given and instrument was shifted after 4th and 11th reading. It was mentioned. We have to find out the RL of all all other points, and RL of starting point was given, it is 80.750, and we have to calculate the RL of all other stations. So for calculating this, we are having two methods. Again, because it was not mentioned that from by using which method we have to solve this problem, so we can choose anyone. So first of all, I am going to solve this problem by using height of instrument method. Okay, so in this problem, I'm going to copy this data. So this is your data. In problem it was mentioned the instrument was shifted after 4th and 11th reading. So 1 2 3 4, this is your first change point, and I think 4th 5th 6th 7th 8th 9th 10th 11th, so this is your second change point. So it is CP1 and CP2, change point 1 change point 2. So we are going to solve this problem by using height of instrument method. So first of all, we will draw one standard table. This is our table for height of instrument method, in which first column is for station, second column is for backside reading, third side is IS for intermediate side reading, FS for foreside reading, and HI is height of instrument. Next is RL or elevation of all points, and last column is for remark. So stations are the marking on the stations, like ABCD was marked there. So we can mark, but in question it was mentioned that it was a 30-meter interval. So I have mentioned it is in two forms, uh, ABCD. Okay, ABCD, and I have marked it in the form of chainage. Means station A is 0 meter apart, and station B is 30 meter apart, and station C in the form of 30-meter intervals. I have marked the stations. So it it is a standard format. Now it was our change point, 4th and 11th reading. So you can see it is our first setup. This is your second setup, and this is your third setup. So this is CP1, change point 1, and this is change point 2. In this problem, we have set our instrument three times. First of all, we have take this reading, then we have shift our instrument here, and third time we have shift our instrument at CP2. So in question, it was mentioned that RL of first point was 80.75. Okay, so we know the elevation of first point, so it will be your backside reading. Okay, so back station A, we are going to say it is 80.750. So it will be your backside, and it will be your last setup reading is four side reading, and all other readings for this setup it is your intermediate side reading. So I'm first reading will be here, backside reading, and station B's reading is here, station C's reading here, and last reading is falling, means fourth reading is falling in four side reading. So it will be your entry. It is your first setup reading. Okay. After this change point, we will take a backside reading again at same station. Okay. So it will be your backside reading for second setup, and it will be your four side reading for second setup, and these are your intermediate side reading. So again, we are going to start from here. So it is your backside reading, and for intermediate, and it will be your four side reading. So we are following this sequence, and it is your entry. Now this is your change point. So after this four side, again it is your backside, it is your four side, and this one is your intermediate side. So we will start from here. So it is your entry for third setup. So as in your problem, it was given the RL of elevation of point A, and we will put the remark. Remark will be your starting point, end point, and change point. So we will mark everything in the remark. So and A's elevation. So A's elevation is already known. So it is 80.75. Now we have to find out the HI. So for this method, I am going to write two formulas. First of all, I am going to write HI. HI is equal to RL plus backside. Okay, it is the most important formula for calculating the HI. So whenever you will see a backside, that time we will calculate the height of instrument. So you can see in this problem there are three backside, so there will be three HI. First HI will be here, second HI just because here it is backside reading is there, so here will be one HI, and here will be one more HI. So three times we will calculate the HI. Okay, but we have to follow the sequence. Now I am going to write a second formula for RL. RL is equal to HI minus intermediate side reading or four side reading. So it is your second formula for calculating the RL. So I am going to calculate first HI here. Okay, it is your RL of this station, and this is your backside reading. So HI will be equal to summation of this backside and RL. So it is your HI. Okay, now we have to calculate the RL. So formula for RL is equal to HI minus intermediate side or four side. Okay, so you can see for this setup, this is your this this is your height of instrument. So first backside which will be used for calculating the HI, and all other readings means intermediate side and foreside will be useful for calculation of RLs. So this HI will be calculated up to the point D, means up to this point we can calculate the RL of RL by using this HI. So what we have to do, only we have to deduct these values, means intermediate side and foreside values from HI. So HI is constant for this setup. This one is your HI. So when we will deduct these values, we will get the RL of these points. So these are your RLs, means this is the difference between this HI and this, and difference between these two, this is your RL. So up to this point we have calculated the RLs. Now we know the elevation of this point, and back side is this one is your back side. So what we have to add these two, then we will get the new HI. So it is your second HI. It is summation of this and this. Okay. So we will get this. Now this HI is constant up to this point. Means this is your new setup. So it is height of your instrument. Now we have to deduct these values and we will get the RL of this point. So these are your answers. Okay. Now we have to calculate the next HI. So this is your next HI. It is the summation of this and this. That time we will get our new HI, and this is your third setup. So we will deduct this value. That time we will get the RL of this point. So these are your RL. Now we have to we have calculated all the RL. Now we have to apply one arithmetic check for this problem. So arithmetic check is there. So it is summation of backside sum minus summation of foresight. It is equal to last RL minus first RL. So summation, we will calculate the summation of backside and foresight. So this is your summation of backside, and this one is your summation of foresight, and this is your last RL, and this one is your first RL. So if you will calculate this value, that time it will be 0.905. If this equation is satisfied, that time you have calculated this problem, means calculations are correct. Okay, this indicates the calculation are correct. I hope you have solved this problem. Now we are going to solve a second problem. This problem is belongs to continuously sloping ground. So for continuously sloping ground, I would like to draw one diagram here. Okay. In case of continuously sloping ground, you can see in this problem there the change point is not given. So we have to find out the change point because it is a problem of continuously sloping ground. You can see here the trend of readings. It is continuously increasing. Means uh, inc- you can see here continuously increasing. It means we are going downside. Survey work is conducting downside because suppose we are setting our instrument here and we are plotting our staff in such a way that time staff reading will continuously increase. Okay, but suppose there is suddenly we are changing the station, that time staff reading will suddenly fall. So in this sequence, we can see the staff readings are increasing up to this point, but here it was suddenly falling. So it will be your first change point, and again you can see readings are increasing, and here you can see the staff readings are decreased, and again okay. So these are your change points. In such a way, we have to find out the change point in case of continuously sloping ground. So we are going to solve this problem. So these are your readings, and it is the problem of continuously sloping ground. So we have to find out the change point. So here we are saying, okay, in this case, suppose it is a continuously sloping ground again, but we are conducting the survey in upward direction. That time staff reading will, you can see the trend of loading. It was here, it will be highest in first setup, it will be highest reading, then continuously readings will decrease up to a certain point. If there is a change point, that time staff reading is suddenly will be increased. So will be the sequence of continuously sloping ground. So in case of hmm, decreasing gradient, that time the staff reading will, this will be sequence of continuously sloping ground in case of downward direction. So these are your readings, and we are going to solve it by using rise height of instrument method. So I am going to mark change point here. So it is your first change point, and this one is second change point. So staff, these are your stations, and I have entered the first setup reading. So as you are aware, this one is your change point. So we will put first reading in backside and last reading in foresight. So this will be your entries, and then it will be your backside reading, and this reading will be your foresight reading. So we will start from here. Okay. So it will be your entry, and third setup will be this. Okay, and RL of first point was given, and these are your remark. Now we will calculate the HI. HI is equal to summation of backside RL. So this will be your HI. Now we can calculate the RL of this point by using this reading. Okay, only we have to deduct this value from HI. So HI is constant up to this point. So these are your readings. It is the difference between these. Okay. Now this is your second setup. So our second setup, again we have to find out the HI. So for HI, this one is your RL and this is your backside. So it is your new HI and these are your next RL. Similarly, we will calculate this HI. Okay, this is your third HI and these are your RL. Again, there is one check. So this is your arithmetic check. Summation of backside minus summation of foreside is equal to last RL minus first RL. So I think these are the summations and these are the value. Okay, so I think this, I hope you understood how to calculate the change point or how to find out the change point, and then we will solve this problem. Okay, again, it is your same problem. It is continuously sloping ground, but here readings are decreasing. Decreasing in the sense we are going in upward direction. Survey is conducting in upward direction. So these are your entries. Okay, just because first change point is here, second change point will be here. So this is your first reading. These are your second set of reading. This is your third set of reading. So this is the elevation of A is known. So we are going to solve. So the RL of A is known. Now we have filled the remarks and this is your HI, and we have calculated the other points, means up to this point we have calculated the RLs by deducting this value. Okay, so most important thing is to calculate the change point by, in this problem. So this is your second HI. By using this and this we have calculated the HI. Okay, now we have to calculate the RL of this point. So it will calculated by using this will be your HI and we will deduct this value. That time we will get the RL. So these are your RL. Again we have calculated the RL of this point. We have to calculate, this is your backside. The backside will be useful for calculating the HI. So it is your HI, new HI, and we have to again we have to calculate the RL. So this will be RL and this is your arithmetic check. Now second method is rise and fall method. So again, first problem is there. We are going to solve this problem by using rise and fall method. So these are your readings, and these are your fourth and 11th point is your change point. So again, we will draw a table. So in this table, I, up, stations are there, backside is there, intermediate side. Okay, one new thing is there, rise and fall. Okay, we have to create a different column for rise and fall, and next column is elevation, and last is remark. So I hope you are aware how to fill this reading and this. So RL will be a calculation part and rise and fall will be a new thing. So we will start to fill this data. So fourth point is your change point, and I think this one is your change point. So we will start to fill this data. So first of all, stations are there, and these are your readings. Okay, so this is your first setup, second setup, third setup. First of all, let me fill the all remarks, etc. So you know the remarks and you know the RL of first point. So here you can see it is your first setup. So I'm going to first of all going to solve the first setup. So in first setup you can see the station A reading is less as compared to B. So when you will compare these two, so you can see the ultimately the elevation is falling. Okay, next, so we will compare these two and you can see the elevation difference between these two stations. So if I will deduct first reading minus second reading means first minus second means suppose I have to compare this to B because I cannot compare A with anyone right now because A's reading is only one there. So I'm going to compare the second reading. So you can see first reading minus second reading. That time I can directly say this station is 0.775 meter down from station A. So station A's elevation we know, and we have calculate the fall of these two. So similarly, we will calculate the difference between second and third and fourth. That time we will find out these values. Okay. If it is negative, that time we will say it is fall. If it is positive, that time we will put in it is in rise table. So like in such way, it is the difference between these two. Difference between these two is there, and difference between these two is there. Okay. Next, we have to calculate. We have done the calculation of first setup. For second setup, we will compare this starting readings from second setup. Okay. So here we will compare these two readings here. The comparison between these two will be here. Comparison means difference between these two will be here. Okay. If it is positive, that time we will fill it in rise table. So this is your comparison of second table, and last is your these readings are your last reading. Okay. Uh, a difference between these two is here. Difference between these two is here. Difference between these two is here. Now we know this. When we are going to A to B, that time that much fall. So we will deduct. Means I can say RL this plus this. Okay, with sign we can say. Plus means you have to consider the sign. Okay, this plus this is the RL of this point. So these are the RL. The summation of these, summation of this, summation of this, summation of this, summation of this means sum of these two, sum of these two means now it is a relay in replicating the formulas. So this is the difference or summation, and this is the summation of this. So it is your rise and fall method. So again, there is one formula for arithmetic check. So we are applying arithmetic check for it. So arithmetic check is summation of backside minus summation of foreside is equal to rise. Summation of rise minus summation of fall is equal to last RL minus first RL. So in this check arithmetic method, there are one more check is there, summation of rise and summation of fall. So you can see in this method summations are there. So this is the summation of backside, summation of foreside, summation of rise, summation of fall, and this is your last RL, this is your first RL. So if you have solved it correctly, means solved, only calculation we can say, that time this equation will be satisfied. Okay. Similarly, if you know how to fill the data, that time you can solve all the problem in given worksheet. So I hope you got how to calculate the other points. So I think this one is your last problem in your worksheet. Okay. In fly leveling. Okay. In fly leveling, what will first of all you should know how to what is your purpose of fly leveling. Purpose of fly leveling is suppose this is one ground. Okay, A and B, there are 2 points on the surface of a and B which are two apart. Okay, means suppose it is your tripod and we have if so it are these stations are not intervisible. So what we will do, our target is to calculate the RL of B. We know the RL of A. Our target is to calculate the RL of B. So what we will do, try to we will start to go towards the B. In such a way we don't require the intermediate stations reading. So what we will do, we will take a backside reading and foresight reading, and we will shift our instrument in such a way that we will reach towards our station B. So it will be again your backside and it will be your foresight. Okay, in third setup it is backside and this is your foresight. So in this method there will be not any intermediate side reading. So you can see station A is, there is one single reading at station A and B, but at intermediate means mediate stations there are two readings. One is foresight, second is backside. So I can say it is first reading, this is your second reading, third reading, fourth reading, sixth reading, fifth, sixth. Okay, so first reading is backside, second is foresight, third is backside, fourth is foresight, fifth is backside. So I can write here it is backside, foresight, backside, foresight, backside, foresight, backside, foresight, and these are your change points. Peter. Change point, change point, change point, change point. So there are not any, there is not any intermediate side reading. So okay, so this is the solution. This is your first reading, this is your second reading, this is your third reading, this is your fourth reading, fifth reading, sixth reading, seventh, eighth, ninth, 10th, 11th, 12th, 13th, 14th. So these are your sequence. Okay. So rise and fall. We have to find out rise and fall. So it is your previous. So the difference between these two will be either rise or fall. Difference between these two. Sorry. Difference between 3 and 4 will be rise of fall of second next station. 5 and 6 we will compare. 7 and 8 we will compare this because these are different setups. So we will see it is rise or fall. So you can see here all the difference are coming in positive manner. Now we have add this addition of this, addition of this, addition of this, addition of this, addition of this. Okay, so these are your solution and these are summation and this